Imagine a world where your steak, burger, or chicken nugget is grown not on a farm but in a lab. What if we could produce meat without the need for raising and slaughtering animals? Welcome to the fascinating realm of lab-grown meat, a technological marvel that promises to revolutionize our food systems. But is it real, and what does it mean for our future? In today's video, we'll explore the concept of lab-grown meat, also known as cultured meat. We'll dive into its scientific foundations, understand the ethical implications, and discuss the potential it holds for feeding a growing global population sustainably. Stick around as we unravel the truth behind this cutting-edge innovation and see if lab-grown meat is truly the future of food. As we venture into this topic, consider how our food production methods have evolved over time. From hunting and gathering to modern industrial farming, each step has brought about significant changes. Now, with lab-grown meat, we stand on the brink of another major shift. Could this be the answer to the environmental and ethical challenges posed by traditional meat production? Let's find out together. Lab-grown meat, often referred to as cultured or cell-based meat, is a groundbreaking development in food technology. But how did we get here, and what exactly is it? To answer these questions, we need to take a step back and look at the history and basic principles behind this innovation. The journey began with the growing concerns about the environmental impact, ethical issues, and sustainability challenges associated with traditional meat production. Raising animals for meat requires vast amounts of land, water, and feed, and it contributes significantly to greenhouse gas emissions. With the global population projected to reach nearly 10 billion by 2050, finding sustainable ways to produce food is more critical than ever. Lab-grown meat addresses these concerns by cultivating animal cells in a controlled environment to produce muscle tissue, which is essentially what we consume as meat. The idea was first proposed in the early 2000s, but it wasn't until 2013 that the first lab-grown burger was unveiled by Dr. Mark Post at Maastricht University. This burger, created from cultured beef cells, marked a significant milestone and demonstrated the feasibility of producing meat without the need for livestock farming. Since then, numerous companies and research institutions have entered the field, working tirelessly to refine the technology, improve the taste and texture, and reduce production costs. Today, lab-grown meat is not just a concept but a reality, with several startups already producing small quantities of cultured meat products. The basic process involves taking a small sample of animal cells, usually from a live animal, through a biopsy, and then proliferating these cells in a nutrient-rich culture medium. The cells are encouraged to grow and differentiate into muscle tissue, which is harvested and processed into various meat products. This method has the potential to produce meat with a significantly lower environmental footprint and without the ethical concerns associated with conventional meat production. As we move forward, the big questions remain: can lab-grown meat scale to meet global demand? Will it be accepted by consumers? And what regulatory hurdles need to be overcome? These are just a few of the intriguing questions we'll explore in the next sections. Furthermore, consider the impact on our dietary habits and food culture. Will lab-grown meat taste the same as conventional meat? How will it affect the culinary traditions that many cultures hold dear? The answers to these questions will shape the future of our food landscape. As we delve deeper into this topic, keep these thoughts in mind and think about your own perspective on this innovative approach to meat production. To understand the science behind lab-grown meat, let's delve into the core processes that make it possible. At its heart, lab-grown meat production involves the cultivation of animal cells in a controlled environment to form muscle tissue, which we then consume as meat. This process is a blend of biotechnology, tissue engineering, and food science. The journey begins with the selection of the appropriate cells, usually stem cells or satellite cells, from the desired animal. These cells are capable of proliferating and differentiating into various cell types, including muscle cells. The cells are placed in a bioreactor, a device that provides the ideal conditions for cell growth, including the right temperature, oxygen levels, and nutrients. One notable experiment in the field was conducted by a team led by Dr. Mark Post, who created the world's first lab-grown burger. This project used bovine skeletal muscle stem cells, which were cultured in a nutrient-rich medium containing amino acids, sugars, and growth factors. Over several weeks, these cells multiplied and formed muscle fibers. The result was a small piece of beef muscle tissue, which was then combined with other ingredients to create a burger patty. The science behind this process is complex but fascinating. Cells require a scaffold or structure to grow on, which mimics the extracellular matrix found in animal tissues. Researchers use various materials for scaffolds, including collagen, plant-based gels, and synthetic polymers. These scaffolds provide the necessary support for the cells to form organized muscle tissue. Another critical aspect is the culture medium, which must supply all the nutrients the cells need to grow and proliferate. Traditionally, this medium includes fetal bovine serum, a byproduct of the meat industry. However, to make the process more sustainable and ethical, scientists are developing serum-free media, which use plant-based or synthetic alternatives. In addition to muscle cells, fat cells are also cultured to enhance the flavor and texture of the final product. These cells are grown separately and then combined with the muscle tissue to create a more realistic meat-like experience. The goal is to produce lab-grown meat that is indistinguishable from conventional meat in terms of taste, texture, and nutritional value. While significant progress has been made, challenges remain. Scaling up production to meet global demand, reducing costs, and ensuring the safety and quality of the final product are ongoing areas of research. Nevertheless, the scientific foundations of lab-grown meat are solid, and the potential benefits for sustainability and animal welfare are immense. As promising as lab-grown meat sounds, it is not without its ethical challenges and potential problems. One of the main ethical questions revolves around the use of animal cells and the need for fetal bovine serum in the culture medium. Critics argue that this still involves animal exploitation and does not fully eliminate animal suffering. Dr. Vandana Shiva, an environmental activist and food sovereignty advocate, has expressed concerns about the implications of lab-grown meat. She argues, lab-grown meat is a technological fix that doesn't address the root causes of our broken food system. It perpetuates the idea that we need to dominate and control nature rather than working with it. Source: The Guardian. Another concern is the potential impact on traditional farming communities. If lab-grown meat becomes widespread, it could disrupt the livelihoods of farmers and those involved in conventional livestock production. This raises questions about the social and economic consequences of transitioning to a lab-grown meat industry. Moreover, there are debates about the nutritional profile of lab-grown meat. While it can be engineered to contain specific nutrients, some argue that it may lack the complexity and variety of nutrients found in naturally raised meat. This could have implications for long-term health and dietary balance. There are also environmental considerations. While lab-grown meat has the potential to reduce the environmental footprint of meat production, the energy requirements for large-scale cell culture and bioreactor operations could be substantial. Ensuring that these processes are powered by renewable energy sources is crucial to realizing the full sustainability benefits. From a regulatory perspective, lab-grown meat faces significant hurdles. Governments and regulatory bodies need to establish frameworks for ensuring the safety, labeling, and marketing of these products. This involves rigorous testing and evaluation to meet food safety standards and to gain consumer trust. Despite these challenges, proponents of lab-grown meat argue that it offers a viable solution to many of the problems associated with traditional meat production. It provides a way to produce meat without the ethical and environmental drawbacks, potentially transforming the way we feed the world. Additionally, the cultural acceptance of lab-grown meat varies across different societies. In some cultures, meat consumption is deeply intertwined with traditions and social practices. Convincing consumers to switch to lab-grown alternatives may require significant efforts in education and marketing. The psychological barriers, such as the perception of lab-grown meat being unnatural, also play a crucial role in its acceptance. As we weigh these ethical considerations, it's essential to continue the dialogue and involve diverse perspectives. Only through open discussion and collaboration can we address the concerns and harness the full potential of lab-grown meat. In conclusion, lab-grown meat represents a remarkable innovation with the potential to reshape our food systems. It offers a solution to some of the most pressing issues of our time, including environmental sustainability, animal welfare, and food security. However, it also poses ethical, social, and regulatory challenges that need to be carefully addressed. As we've explored, the science behind lab-grown meat is both fascinating and complex, involving advanced techniques in biotechnology and tissue engineering. While there are still hurdles to overcome, the progress made so far is promising. We'd love to hear your thoughts on this groundbreaking technology. Do you believe lab-grown meat is the future of food? What ethical considerations do you think are most important? Leave your comments below and join the conversation. If you found this video informative, please give it a thumbs up and subscribe to our channel for more content on the latest innovations in science and technology. Thanks for watching. Moreover, consider the broader implications for our society. How will lab-grown meat impact global food security, especially in regions struggling with food shortages? Will it help reduce the environmental burden of agriculture, or will it introduce new challenges? Your insights and opinions are crucial as we navigate these complex issues together. And don't forget to share this video with friends and family who might be interested in the future of food. Together, we can spark meaningful conversations and drive positive change. Thank you for being part of this journey with us. As we look to the future, the potential for lab-grown meat to create a more sustainable and ethical food system is immense. Imagine a world where meat production no longer contributes to deforestation, greenhouse gas emissions, or animal suffering. This vision is within our reach, but it requires continued innovation, investment, and public support. What do you think will be the impact of widespread adoption of lab-grown meat on traditional farming communities? Share your thoughts in the comments. Don't forget to like this video and subscribe to our channel for more content on the latest innovations in science and technology. Thanks for watching.